Dr. Ramori again with a new experiment. This experiment is about oxidation of an aromatic compound with alkyl side chain. The purpose of this experiment is just to study the oxidation reaction and also learn about the reflux when reflux is needed for a chemical reaction. Under what condition we are using reflux? Reflux, the setup for reflux is very similar to distillation, with exception that we are going to set up the condenser upright. That means that when the vapor of the solvent is going to move up, it's going to condense and it goes back into the boiling flask. The purpose of the reflux is to provide heat for a long period of time for chemical reaction that requires heat. So our chemical reaction requires heat and requires heat for a long period of time. Because if it was just bring the mixture to boil and cool it down, we didn't have to use reflux. But because we are going to use the reflux for like 1 hour or heat the reaction mixture for 1 hour, we have to use reflux to avoid losing or drying of the solvent. In this case, the solvent is water. But can you imagine if the solvent is acetone or if it's alcohol or any other organic compound, we don't want to have the vapor of that solvent in the lab as well. So first, I'm going to show you how to set up the reflux. I'm going to start with the ring stand, and we are using hot plate. This hot plate is not used to provide heat for our reaction. What it is used for is to get the use the stirring function of the hot plate and using magnetic stirrer. So when we turn on the stirrer, the magnetic stir bar is going to spin and stirs the solution. I'm using a heating metal and a power regulator. Heating metals are not designed to be connected to the wall, so we have to connect it to the power regulator, and the power regulator is going to be connected to the wall. I like to test the system, our heating system first before I finish up the setting up the reflux, because I don't want to finish everything and turn it on and the heating system is not working. I'm going to turn on to check the system is working, is heating up. And as soon as it starts warming up, I know the heat is in place and is working, and I will stop the heat. I don't have to heat this for a long time. Just waiting for something to happen here for the heat, for heating metal to warm up. Okay, the system is working, so I'm going to turn it off, unplug for now, and set up the reflux. Just like simple distillation or just like any distillation, hardware should go in first before I bring any pieces of glass. Using utility clamp to secure the boiling flask. And I'm using a 3-finger clamp to secure or hold the condenser. The good thing about this 3-finger clamp is that it has adjustable arm length and it can turn around and adjust the angle. Now that I have my needed or required hardware, I'm going to bring pieces of the glass that I need for my reaction. I am using 250 milliliter boiling flask. And the amount of the sample that we are going to put based on the procedure is about just 50, 60 milliliter. But the size of the flask is chosen, the large size, is because this reaction is going to produce some manganese dioxide as a solid compound, and it can generate like a lot of like bumping. To avoid the bumping, we have to stir the mixture constantly. We have to have enough space here, so when boiling takes place or bumping takes place, it's not going to shoot out of the condenser. And we also regulate our heating to make sure that we provide gentle heating only, not fast heating. So I use the utility clamp to secure the boiling flask, and I bring the condenser. Anytime we connect two pieces of glassware, especially when the heat is involved, we need to grease the glass joints. The purpose of greasing glass joints is the same thing as distillation. I'm referring to distillation because you see how similar is the setup to the distillation, to avoid freezing of the glass joint so we can easily separate. And the other purpose is we want to make sure that we have a sealed system, because if this connection here is loose, when the whatever liquid you have here or reaction mixture when it starts boiling, the vapor is going to escape from here and not to go up on the condenser to be condensed and return. I also like to use a keg clamp or blue clamp that we have here. And the way that it goes with the smaller circle, larger circle, we say when you have like glass joint, make sure that this glass joint is, you're watching the joints. So you have smaller part here, larger part, and this ring, the opening of this ring just goes right in between. The smaller side should be placed on the small side and the large one on the large side. You hold your thumb underneath and you press it from the top like this to avoid like breaking of the glass. So to take it out, if you place it properly, it's going to be easy. But if it's the wrong way, that means you have to force this to get it in. It's not going to work. And I'm not trying to break this. I'm just trying to show you how wrong placing is not effective. It's not going to hold the piece of glass together, and you end up breaking and the clamp also. So we are placing this keg clamp around the ring, right? The small part top and the larger part at the larger side. The water hoses are used in this case because our solvent is water, has high boiling point. The air condenser is going to be sufficient enough or efficient enough to cool down the vapor and return. But just in case, in an emergency, in case if the boiling is too fast or too much vapor is going up, or the mixture is boiling off the condenser, we turn on the water. The water should go in from the lower end and comes out from the upper, and make sure that this water hose, it's loose and it's just going down this waterway and is going to waste. I have seen often students connecting the lower end to one hose faucet and the upper one to another, which is going to be a disaster. It puts a lot of pressure and the hose comes out and we have water splash here. So the setup now is complete. I just want to secure the pieces of glass by tightening the clamps, and I like to get this like straight up. So I work with this to make sure that is straight. The size of the heating metal, it has to be proper for the size of the boiling flask that we are using. I want to make sure when students are in the lab, they set up the reflux system first. Then we remove the boiling flask and add the pieces that is needed to be added to the boiling flask that's required for the reaction mixture. 1.8 grams, about 1.8 grams of potassium permanganate, 1 milliliter of the aromatic compound, And we are adding 2 to 3 pellets of sodium hydroxide. This reaction or this oxidation reaction is taking place in basic solution. The reason we are going with basic solution because the product of this reaction is benzoic acid. If the solution is neutral or if it is acidic, the benzoic acid is going to precipitate. And when it does precipitate, you have those like white, nice crystals mixed with the mud of manganese dioxide, which you won't be able to separate it. So we want to make sure that our product, which is the benzoic acid, is going to stay in the liquid form, in an aqueous solution form, in a basic solution, because when you add the base to the benzoic acid, it reacts and it gives sodium benzoate, which is water soluble. And you can use the gravity filtration and separate before you recover the sample. If the solution is neutral, I'm just repeating, if the solution is neutral or acidic, benzoic acid is going to precipitate and be mixed in the mud of manganese dioxide. So I'm going to separate the boiling flask. Now that I know my setup is proper and is approved by the professor, I separate the flask, I get the chemicals.